so let's see nitrogen compounds. How primary and secondary amines are produced. The first reaction. The first reaction is going to be you use excess ammonia. In ethanol or ethanolic ammonia excess under pressure. It means at high pressure. So we are going to get amine. How do we write that? So what reacts? Basically this is going to be halogenoalkane. Halogenoalkane. So I will actually use this example, maybe CH3Cl. Halogenoalkane. CH3Cl, when you react with ammonia, under the condition mentioned, what you will get CH3NH2 plus HCl. So you do get amine. This is going to be one of the reaction. Now, another reaction is, remember I told you it must be in excess. Why? If it is not in excess, then you are going to have the reaction with amine. So here they say plus with primary amine in ethanol condition and seal tube under pressure is the same condition. So let's say this one is a primary amine. So let's say I just use the same example, CH3Cl. They can react with a primary amine. So they are going to give you, they are going to give you CH3, and then you will have the one H over here, and this Cl will give you HCl. So you will have the nitrogen, one hydrogen, and then you have CH3. So this is a substituted, amine. So you are going to get a substituted amine if you are reacting. So this is going to be the second reaction. But both of them are going to be reaction of halogenoalkane. But that is not the only reaction with the halogenoalkane. So I'll just erase this one. There are three. There are three. There should be three. I miss out this one. This one also has relationship. Reduction of nitriles. With LiAlH4. So if let's say for example nitriles. How do you get nitriles? You get nitriles whenever you have this CH3, any halogenoalkane, when they react with KCN. KCN must be in ethanolic condition. And then you heat up, you are going to get CH3CN. And then KCl. This is what they call as nitrile. Now this reaction don't stop over there. This nitrile CH3CN, they are going to be reduced by two reducing agent. Either you can use LiAlH4 in dry ether. In dry ether, or you can use H2 in nickel catalyst. Please ignore this. This one I don't want to focus over here because it's not in the syllabus now. You use the H plus. So if you use the H, I think when they write the equation they say H or H plus. Let me check. I think H, so no need to put H plus. So I put H only. So what will happen? You need to know that the H will come here, 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 and here. So it must be 4. So you will have CH3, CH2, and H2. So this is also amine. You get, that's going to be your third equation. The fourth equation, is going to be reduction of amide. So let's say I just have one amide over here. This is amide. So if I have any reducing agent, which is LiAlH4 in dry ether, what will happen? You are going to have, this one, the O will come out. So the O will come out. Okay. So the hydrogen will come in here and here. Okay. And then, okay, the O came out. So the hydrogen will join here and also join over here. So how many hydrogen you need? You need total of 4 hydrogen. So you are going to get CH3. Okay, C, H over here, H over here, and H2. So this is also amide. Okay, so how do we get amide in the first place? Okay, this one, okay, how do you get amide in the first place? Okay, the reaction of acyl chloride. Yeah, please remember the reaction of acyl chloride. Acyl chloride can react with ammonia, it can react with amine. Yeah, so you can get amide. From that amide, you can reduce, okay, to become amine. If you look over here, that's 4, okay? So left with another one more, okay? Left with one more, which is going to be, okay, did I miss out over there? Let me see. Okay, I think I missed out that. Hold on. Okay, so there is another one, okay, which is going to be preparation of, okay, basically I'll just put it over here, okay. There's another one which is going to be reaction number 5, which is going to be from benzene, okay. From benzene, you react with HNO3, okay. So you use concentrated H2SO4, concentrated HNO3, okay. You use 55 degrees Celsius, you can get nitrobenzene, okay, and water. Once you get the nitrobenzene, yeah, this nitrobenzene can be changed into phenylamine, okay, by reducing them as well, okay. You can change it into phenylamine, okay, but the reducing agent is different, okay. Please remember, you use SN, okay, tin, yeah, tin, and then you will use concentrated HCl, okay, and then you need to heat, okay, SN concentrated HCl, and you need to heat, and you are going to get, okay, this reaction. Yeah, so you need to know how to write the equation also. So let me try to write the equation. So NO2, okay, plus how many H, I don't know, okay, we can count later. So they are going to give you NH2. So what happened? Okay, the 2O came out. Okay, so you will need, okay, 2 hydrogen came in. Okay, so you need 2 hydrogen here, and you need 1 hydrogen here, 1 hydrogen here to form 1 water, another hydrogen here, another hydrogen here to form another mole of water. So you have 2 H2O. So how many hydrogen you need? Total of 6 hydrogen. 1, 2, 3, 4, 5, 6. Okay, so you need to have that. Okay, so do remember, okay, this reaction, okay, can be reduced to give you that. Okay, so these are the reactions that we need to remember. Okay, we need to remember. So the rest of the reaction, yeah, if you look over here, some of other reactions. So you see the reactions, okay, that we need to remember over here is, okay, when you have ammonia, okay, this is the revision, yeah. So when you have ammonia, okay, when you react, okay, with acyl chloride, because acyl chloride, they can react with both ammonia and amine, yeah. So if you have a particular acyl chloride, let's say this is going to be the acyl chloride, I put the CH3 here, and then this is going to be Cl, okay, so that we can easily see this reaction. So what happened? The one of the hydrogen here and the Cl will come out. So you have HCl plus, okay, NH2, okay, will join with this. Okay, so you are going to get, okay, if I rewrite this, C double bond O, this is CH3, and then NH2. Okay, this is going to be amide. Okay, you're going to get amide. Okay, the same thing if I have acyl chloride. Okay, same if I put the acyl chloride over here. What do I expect? Okay, this Cl and one of the H over here. Okay, they will give you HCl. Okay, and then they are going to give you C double bond O CH3, and then this one bonded to N. Okay, and then it is going to be bonded to hydrogen and bonded to one R group. Okay, as long that they have this one, this is a substituted amide. Yeah, so substituted amide. Okay, so if they ask you what is this reaction, yeah, what is this reaction? Okay, this is the reaction to form amide. Yeah, to form amide. So the mechanism of the reaction. Yeah, so in this case, there's no special name for this. Okay, the mechanism for this reaction is going to be, okay, you need to remember the moment there is acyl chloride. Okay, what is the mechanism, Josh? Acyl chloride reaction, what is the mechanism? Jasmine?
Addition, elimination.
Yes, good. Addition, elimination reaction. Yeah. So do remember this. Okay. So this is the mechanism. Okay. And we have also learned, okay, just now in the beginning, I taught you about basicity of aqueous solution of amine. So if you look at ammonia, okay, ammonia has lone pair. They also have lone pair. This one also have lone pair. Okay, the presence of alkyl group or the R group, they will push the electron over there. Repulsion of the lone pair will be more. Okay, so this is going to become more basic. Here, the lone pair, they try to they overlap with the pi bonding system, making it less available for bonding. So that's why they are less basic. Okay, if you compare, if you have more R groups, okay, for example, like just now we did this example, if you have CH3, CH3, let's say another CH3, what will happen to this lone pair? Okay, if you have more R groups, they are going to be more electron donating group. So they are going to repel this particular lone pair more. So it will become more available to be bonded with H plus. So they will become more basic. Okay, more R groups, they are going to become more basic. Okay, so explanation we already learned. Okay, and then here, okay, phenylamine and azo compounds. Okay, so I just wanted to explore about phenylamine, okay, and azo compound. Okay, how do you prepare phenylamine? Remember just now the fifth equation that I wrote over here. How do you prepare phenylamine? Okay, using benzene. Quite simple. You use the benzene, you use the HNO3, yeah, you use all these conditions, okay, you are going to get the nitrobenzene. Once you have nitrobenzene, you are going to reduce them using hot SN, the hot tin, yeah, concentrated HCl and aqueous sodium hydroxide. This one I didn't put in the notes. Please include that in your notes. Okay, you are going to get, okay, a phenylamine. Okay, once you have this phenylamine, okay, you need to remember, okay, the reactions that is related to phenylamine. Okay, the reactions of phenylamine we are going to learn later. Okay, I have written over here. Okay, but it's okay. We'll just learn now. Yeah, I didn't go through the PowerPoint slide. Okay, so the reaction is going to be similar, okay, to phenol. Okay, remember the reaction with phenol. If you have the phenol, because OH is going to be electron donating group, okay, at room temperature itself, okay, the Br will come over here, Br will come over here, Br will come over here. Yeah, like they will increase the electron density, okay, and it's like remember the thing that I used the term. Phenol is like a hot girl everyone wants, and then they can form the reaction without any catalyst, something like that. Yeah, so the phenylamine also will function the same way. Yeah, because this NH2 is also electron donating group, so they are going to have similar reaction. They are going to be bringing the Br over here, Br over here, and Br over there. Okay, so nothing different, yeah, nothing different. So it's going to be room temperature only, no need any catalyst. Okay, it's going to give you this plus HBr. Okay, you can balance it. Okay, so this one is going to be 3. Now, preparation of phenol. Let's recall. Yeah, let's recall. Remember how to get phenylamine. Okay, you get the phenylamine like just now. Okay, you get it from benzene. Okay, you use the HNO3, you get this part. Yeah, so you will get phenylamine. Okay, now how do you prepare phenol? Okay, please remember. Okay, if this one, okay, they are going to react. Okay, react with HNO2. Okay, this HNO2, okay, they cannot be prepared in lab. Okay, you cannot store in the lab, so you need to prepare them separately. Okay, you use NaNO2 plus HCl. They will give you HNO2 and then NaCl. Do remember this one in 5 degrees Celsius. Okay, so this one, if it is more than 5 degrees Celsius or more than 10 degrees Celsius, okay, the HNO2, okay, will decompose to give you nitrogen gas. Okay, we can recall all this. Okay, so once you have that, okay, you have this, they are going to react, okay, where they are going to give you this N2 plus and then Cl minus. Okay, you will have this. Okay, if I'm not mistaken, this one is going to go there. So you have H, one H, O, another H. So you are going to have 2 moles of water. Okay, you can join and write down. Yeah, 2 moles of water. So once you get this, okay, this, okay, can be used to prepare phenol. Okay, how do you prepare phenol? Okay, you take this N2 plus Cl. Okay, you react with water. Okay, you warm. Okay, you warm this. You are going to get a phenol, and then you will get nitrogen gas. Okay, phenol, OH is gone, so you have H, it's not gone. The N2 came out, okay? So the Cl and the H remaining, so you have HCl, okay? So you will get this, okay? This is how do you prepare phenol, okay? Recalling the whatever things that I taught you. And then diazotization reaction, okay? This is also recalling, it's not something new, yeah? Okay, diazotization reaction, okay? Once you get this phenylamine, okay, phenylamine, okay, we have this phenylamine, okay, will go through 2 steps, yeah, 2 steps. The first step, okay, is the one that I wrote just now, which is going to be these 2 steps over there. Okay, so let's actually copy them down. Okay, you will get a benzene diazo salt. Okay, so first you have this reaction where you have converted them into this N2 plus Cl minus. Yeah, that is what is the first step. Okay, second step, okay, just now the second step was used for the preparation of phenol. Yeah, but if you have this is the first step, okay, diazotization. Second step is called coupling reaction. Now, coupling reaction is where you have the salt N2 plus Cl minus, you react with phenol. And then phenol, the OH is going to be normally 2,4,6 directing. Because the structure is big, they will actually bring to this position. So you are going to get, okay, if I draw OH here, N, and then like this. Okay, so NN, and then plus the HCl. Okay, this one, okay, is going to be known as diazo di. Okay, so this is orange color. Okay, this is going to be orange color. Yeah, and then normally what they do, they don't keep it like this. They try to turn it around this way. So I can also nitrogen, OH. Okay, it's the same. Okay, it's the same. But in your syllabus, okay, this one I told you when I teach you again, I will teach you this again because there is also yellow dye can be formed. Yeah. So sometimes, okay, if you want orange dye, you react with this phenol. Okay. But if you want some other different dyes, then you have to change it only. Yeah. So the material is still going to be with this. Okay, N2 plus Cl minus, but sometimes the phenol is changed. Okay, sometimes the phenol is changed. Like sometimes you will have like nitrogen. Okay, they put CH3, CH3. Okay, instead of phenol. So if you have that, okay, the reaction is going to be. I draw quite fast over here. So you will have. This is still nitrogen. Okay, CH3. CH3. Here you will have nitrogen, double bond nitrogen, and then you have this molecule. So the difference over here is, you see this one ended up with OH, okay? But here you see that this is going to be ending up with some other thing, yeah? So if you have different groups attached, yeah, it is still diazo di, yeah, it's still diazo di, but the color now, okay, because of different groups is being attached, this is going to be yellow. Okay, in your syllabus they want to, yeah, so I put over here instead of phenol. If you react with this, you are going to get yellow dye. Okay, so too many things to process, I know, yeah. This one, that's why I